It's another edition of Water Talks, and the past couple of weeks we've been doing these Thursday editions, just giving you guys a little preview of what's new in Info360. And today we're really going to concentrate on the InfoWater Pro integration side of things. So really excited about this one. Your host today, we have Nathan Gerts, who's a product manager at Innovise. We have Susana Macias Marquez, who is a software QA engineer here at Innovise, and I'm Hunter Sparks, and I'm a systems engineer. So if you've been here before, if you haven't, just a little recap of what this is and the goal. The goal is to create a community where you can come and ask any and all of your questions, and we'll provide answers and give advice and offer some insights. So, a little bit more of an informal feel. You don't have to wait to the end to ask questions. So on the right of, or wherever you have GoToWebinar on your screen, a little ways down, you'll see the questions dialog. Feel free to throw any questions at any time and we'll try to get to those. Some upcoming events and Water Talks. On Tuesday, we have what's new in InfoWorks ICM. On the 16th, we have water main replacement, and we're gonna, talking about Info Asset Planner. And on December 8th, we're really excited. We have an Innovise user group. You should be getting a little bit more information about this, but it's gonna explore 3 of our different products with a utility, a student, and a consultant. So we're really excited to kind of give you a little bit of all the flavors of what we do over here at Innovise. So feel free to join us on any of those. And with all that said, Nathan, I'll go ahead and pass it on to you.
All right, thanks, Hunter. All right, so today we are talking about modeling, and the focus is modeling in InfoWater Pro, and namely kind of where things are headed in terms of like going from like typical modeling to or traditional modeling to enterprise modeling, where you're keeping your model updated. It's serving more of a higher value within the whole organization for operations and maintenance, as well as just real-time assessments of things. And this is also a part of the series where we're continuing to tell the story about like what's new in Info360, which is our cloud platform, which is where a lot of our development and R&D focus is going. And so so jumping into that, we've had over the past decades, there's been this idea of connecting your models with SCADA and like integrating that. That's been something that has been available in different modeling platforms for a long time. We at Innovise, we are the merging of multiple different software companies, really. And so like on the InfoWorks side, which comes from the UK, where utilities are much kind of larger, and they serve that. They've just generally been a little bit ahead in terms of embracing technology and advancements. We do have a lot of history at connecting directly to SCADA and doing even real-time modeling and doing a lot with that. InfoWater Pro, for those who are aware of some of the InfoWater history, we've always had this old SCADA Connect tool that you had to get data into certain text files, and it was never great, you could say. But anyways, all that to say, there have been within the industry the ability to potentially try to just connect SCADA directly to a hydraulic model. However, that has some shortcomings. By itself, it doesn't really solve everything. So what it does give you is potentially real-time access to data. But in many cases, in many utilities, this isn't really an option because the SCADA might be behind firewalls. IT and the SCADA department, don't really provide, open ports through a firewall that modelers could securely access that data, as well as it doesn't provide data cleanup. So sometimes sensors will record bad data, and you can't just pump bad data into the model. You'd actually want to apply some type of cleanup. Whereas on the SCADA side, the data is kind of, it is what it is. In addition, it doesn't really provide pre-processing logic, like turning that raw data into the actual kind of things that your model would need, like maybe complex logic for inferring the actual controls of things in your model. Like if you just have, a kind of a limited view using raw data, you can actually combine that with logic into the actual controls on pumps. So you don't have, the pre-processing logic. You also don't have enterprise collaboration. So this is a big one actually, that I'll come back to in another slide or two. But really, even if you can connect to the SCADA in-house, Innovyze, from a software vendor standpoint, we can't easily support you in that because we can't connect and test things with your SCADA. Also, maybe your consultant doesn't have that connection, so your consultant can't benefit from this process, who is oftentimes the one building and calibrating and updating the model. So it's not really collaborative across departments and environments. Also then, from after you have SCADA into the model, you can't easily share the model results. You can't easily automate the model in real time. And all of that kind of feeds into, you can't really easily achieve a digital twin. So I think you probably know where I'm going with these slides. If instead of just trying to do this raw direct connection between SCADA and the model, if instead we have a cloud platform that can securely tap into the data and provide a hub for data visualization and analytics, and then APIs to not just InfoWater Pro, but all of Innovyze's different models, we get many different benefits for the industry. So you can get that real-time access. Hunter's going to go into some of these on security, data cleanup, pre-processing, such as if you actually have demands that are being calculated, like the actual demands in your model, you don't just measure demands across a zone, you have measurements of flow and tank level changes. So ideally, you could do a mass balance to then infer what that actual usage is in each zone. We can achieve that with Info360. Also, we can have a shared environment between utilities, consultants, and Innovyze for support. We can share model results. You can publish things. Where we're headed is we'll be able to automate things like keeping your model up to date and actually running simulations in real time automatically, and ultimately achieving that digital twin for real time insights and operations. And so this is a slide I've talked through once before, so I'm going to go quickly. Apologize for recycling content, but traditionally, consultants, when they work on a project or a master plan update for a utility, you will have to request data. So you get a bunch of files. Files are fun, and then you will you'll do the model build, importing, allocating demands, setting up pump curves. You'll calibrate the model, adjusting diurnal curves, adjusting controls, comparing and iterating, a number of different times. And once you have that model calibrated, then you're doing different scenarios. So future, demand projections and future capacity updates, capital improvement plans. And to do a lot of that work, InfoWater has features for some of this GIS stuff, but most of the time series work requires a lot of Excel spreadsheet work, which we all love, but it's not very sustainable. And so then once these scenarios are done, then you can deliver your model back to the utility, and it sits as a file that maybe gets referenced, and it may get used in certain workflows, but it's kind of a static copy. And then when there's issues, we may have to recycle this through this whole process if we need the consultant to then kind of get the updated data and look into things and update. So the kind of the future that we see is that Info360 can be kind of this central common data storage. So the utility can securely be integrating this data into Info360. Models can be uploaded. Consultant can access that data, even potentially multiple consultants over time in case you have multiple projects going out to different consultants. And so we can even have collaboration among consultants, and in terms of the latest model. Consultants and utilities can then benefit from a number of these features in terms of time series updates of the model. We'll go into these in more detail, so I won't touch on that. But then beyond just delivering a model, you can also deliver then dashboards and KPIs in terms of model performance, leakage performance, incident management, and so on. And there's a lot more that can go through this. But this is one of the things that we're really excited about, is that in the past, when we've had on-premise deployments that would try to integrate SCADA, every utility has a different SCADA vendor that we'd have to integrate with, and everyone's on a different version of Windows with different versions of SQL Server, and it's a challenge to support, to say the least. And then we couldn't really collaborate with consultants, because then consultants can't really easily, maybe you can try to VPN into a utilities environment, but it just gets to be difficult to solve. But through cloud, we can bypass all of that and finally achieve this collaborative environment where we can all work together and achieve smart solutions. So that's some high-level stuff. I'm going to pass it over to Hunter now to talk a little bit more about some of the things that we actually covered earlier, right, Hunter? Wasn't that last week?
Yeah, we covered a little bit of that last week. We haven't touched on this specifically, but this is one of the important things with moving to the cloud, is we're really improving the ability for modelers to access and use the live data quickly and efficiently. Nathan, I know you touched on that, and the big thing to point out here is not only do you have access to the data online, but then it is ready for your hydraulic modelers to pull it within InfoWater Pro and WS Pro, so you can access it and deliver it right into the model. And one thing that is constantly brought up, we always hear about it, not just on the Innovyze side, but everyone is talking about the security of the cloud as the cloud becomes more prevalent. And we've partnered with AWS to provide a secure environment for Info360, and that's through a shared security model. And what that means is you have the security of the cloud, which refers to the portion that the AWS operates and manages globally, down to the physically secured hardware that hosts visualized computers, storage, database, and network services. But then you also have the security in the cloud, which refers to the Info360 security components, on the Innovyze side of the encryption, firewalls, identity and access management, and data protection of all the customer deployments. And so, yeah, so this is some of the things we talked about last week, but just wanted to touch on it again. Thought it was really important to bring up some data cleanup options, one of which is value mapping. Every sensor system can report or measure bad data. It's just kind of part of the process sometimes. And it is extremely important to fix that before pulling the data into the model. And we have a user interface to assist in cleaning this up and allowing you to apply specific criteria to certain sensors or sensor types. And so, despite the best filters and everyone's efforts, sometimes manual engineering judgment is still the best system. So we have provided a UI for editing tools so that engineers can actually go in and manually edit data when they're looking at it, and they're able to edit these data points within the data set. So whether you're looking for automated or manual fixing, we provide you the tools to really do either. And so, there are really a lot of components that go into ensuring you're keeping your model up to date, updating facilities from GIS, allocating demand spatially, diurnal demand patterns, pumps and valve controls, and calibration. So each of these portions are really important. And with InfoWater and InfoWater Pro, they were really strong with doing the first two, the updating the facilities and allocate the demand spatially. Once you bring in the Info360, the rest of it, that diurnal demand pattern, pump curves, pump and valve control and calibration can be done. But really the important thing to point out is by completing the circle and pulling that Info360 data into InfoWater Pro, you're really able to ensure that your model is calibrated to the current conditions. And so next we're going to transition into the software to show you how some of this is accomplished. But before we do that, want to do a little bit of a level set of the model that we are going to be working in today. It's located in Lakewood, Colorado, and it is divided into 5 pressure zones. But we're going to concentrate on what is known as pressure zone 4 to us, which is on the west side of the site. And within this pressure zone, you'll find, a PRV, some pumps, a reservoir, and a tank, all of which have sensors tied to it, which allow us to isolate the zone and use the live sensor data within Info360 to help calibrate the model. So that's just a level set, and I'm going to, always the fun part of the transition, right, Nathan?
Yeah.
Right.
Do you want to take presenter or should I pass it?
Yeah, let me see if I can do that and see which screen. Let me pull that over. So can
Yep,
you
I can see your screen.
see,
Yep.
and we're looking at Info360?
Yep.
Perfect. So one of the important things that we touched on in the PowerPoint was the fact that you need to be able to look at pump curves. And we've been able to create a dashlet that can bring in that pump data as well as the manufacturer curve to allow you to see if it is operating well against this manufacturer curve, or if it needs some updates, some maintenance, and to see if that maintenance has improved it. And you can look at one pump at a time, or you can actually show multiple pumps on a dashlet. Little bit of a plug, if you want to see how this dashlet here was produced, you can watch our water talk from last week, and we walked through the steps about how you can produce those. And then another example that you can also look at is you can look at multiple pumps within a pump station all on one dashlet to see how it is operating as a whole within that pump station, and you would be able to bring in those multiple pumps as well. So just an example of how you can really look at how your pump is operating in different scenarios.
Yeah, that graph is kind of graying out now, but yeah, that one shows like, yeah, a few thousand data points, and it applies a color ramp according to time. So like, if you applied that to one pump, one time, you'd be able to see kind of a color ramp of if there is any drift in the pump performance against the curve. Just yeah, kind of some interesting tools.
Yeah, definitely. And with the improved dashlets and how they're viewed and some of those added features, it's been really exciting to see where this has gone and where it can go as visually it continues to improve. So the next thing we're going to look at, the always important mass balance, and by pulling in your sensor data, and all of these are actually tied to sensors, what would be sensors out in the field, but also assets within your model. You can really start to break down your model into those pressure zones and start getting that non-revenue water and that information, not just as a whole, but as each individual area. So you can pull in your inflow, your outflow, your storage, as well as your billing data to start getting a lot of that information. And so we're going to move on over to the patterns, and this is going to be, really important in Info360, but also this is going to be what we can pull into InfoWater Pro to really start helping with that calibration. So as you can see, it produces a 24-hour diurnal curve. This becomes really important. And once you've created these patterns, it can be brought into the model, which allows for additional calibration using the sensor data that we've looked at, using this pattern and pulling it into InfoWater Pro. And at this point, we're going to transition over to the InfoWater Pro side. So I am going to hand it off to Susanna. Susanna?
Yeah, so
Thank you.
Hunter, just to recap, so we can connect the data from on-premise, like from your SCADA historian up to our cloud. We then help with the cleanup of that data. And then as part of the implementation, you assign those sensors into each zone, the role for the mass balance. And then we can create these patterns within Info360, and you can choose any time frame, hourly pattern or weekday, weekend, and then these patterns are then immediately available in InfoWater Pro. Yeah.
Yep.
Okay. Yep.
That was a great overview of how it's all tied together.
Yeah. And so yeah, as I'm clicking to make Susanna presenter, and as we're transitioning that, one question came in. I think we could answer now. I want to save another one for the end. So the question is, any machine learning or AI available for data cleanup and analysis? That's a great question. So we do have a team of developers using machine learning and AI within our Imagine team, and much of that process. So they work a lot with water quality data as well as other sensors within the plant, and they're doing some really cool things in terms of setting up kind of like mini models within that data and how they handle it and clean it up and infer data out of it using machine learning. So we are we are still kind of building our skills and internal library. So far, those features have not been merged into the Info360 Insight platform, but I know that is something that we are definitely planning on as that Imagine software and product team continues to grow. So right now that whole platform was developed before we started work on Info360, and it is in the process of being merged into all of the same platform, into the same data environment. And then we're going to have access to a lot of that machine learning type capabilities. So all that to say, yes, it's in the future. I can't speak to any timelines at this point, but that's something I'm definitely really excited for.
And another question on here, just because it does get asked a lot, so I'm sure other people were wondering. The webinar is being recorded, and if you have registered for it and signed up, then you will be sent a link if you need to view it later. So just wanted to let people know.
Sorry, give me just one moment while I set my Teams under Do Not Disturb. Forgot to do that. Yeah, thank you guys. So right now we are within the InfoWater Pro interface, the desktop application. And what we hope to show you through here is just a general workflow for working within the live data adapter feature in InfoWater Pro, obtaining information, connecting to Info360, and then also using that information for calibration purposes within the InfoWater model. So from the InfoWater Pro ribbon, you can go ahead and click on the live data adapter. And the first step would be to go ahead and log into your Info360 account. You can do that by clicking on this data connection dialog, making sure that the Info360 radio button is selected, and then logging in. For the purposes, yes, go ahead.
Sorry, yeah, I want to just mention one thing. So here in this webinar, we are talking about using Info360, and so Info360 is kind of the focus. But if you don't have Info360, you can choose that other radio button, the SCADA Historian Database, and then a number of these tools are available for sensor comparisons to the data, but it doesn't affect the hydraulics. So that's the only difference. But you can potentially connect to like a SQL Server or Pi database, Oracle within your network. But yeah, for the purpose of this webinar, we're going to be focusing on Info360 integration.
Yeah, thank you, Nathan. But yeah, you simply log in through the data connection radio button, log in, and then after that you should be synced in. From here, you can access add sensor data or also add pattern data. And this is one of the features that we want to kind of focus for a little bit here first. We can go ahead and click on this new pattern button. And then within this dialog, we can go ahead and access any of the Info360 patterns that are currently within the account, and proceed to go ahead and map that towards one of the InfoWater Pro patterns. So in this case, I'm going to go ahead and map the Zone 2 demand pattern average to the Info360 account. And you can go ahead and click OK. After you get a confirmation, you can go ahead and select that pattern and preview and be able to evaluate how it matches up. So as you can see, the Info360 pattern data is fairly visible against the Zone 2 demand pattern average. So something that we can go ahead and do, or something that might be required, is to go ahead and use the normalized Info360 pattern data so that we can evaluate this data more on par. So now, as you can see, we can see how the Info360 pattern data compares to the diurnal curve that we have stored within the InfoWater pattern. If you switch over to the sensor tab, we have the capability of importing a batch of sensor data or exporting anything that we have already mapped into an CSV file for later use or for editing. And hopefully that will make the process of mapping sensor data a little bit more streamlined. To do so manually, individually per sensor, you can go ahead and click on the Add Sensor button right here. And we should have access to this dialog that allows us to select the sensor from Info360 that we want to map to an element within the InfoWater model. For the sake of this demo, we went ahead and already mapped our sensors ahead of time so that we can kind of walk through the process a little more streamlined. But essentially, the procedure would be to identify the sensor from Info360, what element ID, and ensure that the values and factors correspond so that they are properly assigned. Within the sensor tab, we can also go ahead and run a gap analysis. So I'll go ahead and display that here. And I apologize, my computer has a bit of a slow response time at the moment. But we can go ahead and proceed to see what is the gap summary of information between each one of the sensors and the corresponding element in the InfoWater model. Within these, we can also go ahead and evaluate individual gap summary reports for each one of the sensors and the corresponding element. Some other features that we can consider through here is we can sort the sensor ID by clicking on the header, either by sensor ID name, sorting descending, sensor type, description if we had to have that, or element ID. Within the actions dialog, or the actions, column, we can go ahead and zoom to an element. So for example, if we wanted to see where this was located in our map, we can go ahead and zoom to that location. And I'll go ahead and zoom out a bit. And we can see where that is generally located. If we want to edit the mapping, you can go ahead and click on this edit feature and proceed to adjust the mapping information. Or we can also go ahead and delete the sensor from our list. So I will go ahead and close out the live data adapter for the moment, but we will come back here to review the gap analysis as we discuss some calibration workflows that we foresee for this application. So first of all, let's go ahead and run the Info360 SCADA run. You can run from info360.com directly, where it will pull and write this particular file and run the SCADA run. We went ahead and did that ahead of time, so we now can go ahead and just do it a little bit faster through the browse to SCA SCADA file. And click OK. And now from our output drop-down, we can go ahead and see that our current run simulation is corresponding to the active SCADA output. If you open the report manager, you'll also notice that the available output source is specific to SCADA. That means that this simulation was run based on SCADA correlations to the model. But the tabular report, graph report are very similar in that we have the same type of information. So I want to go ahead and take a look at tank T5004. So we have our output information as we normally do, and we can also go ahead and click on the graph button. And from here, we can go ahead and see how the tank T5004 compares to the level of T5004 based on the SCADA run. To bring this dialog about, you simply have to go ahead and click on the live data button and then select the tank and the date of the data sensor that you want to measure. So from this point, we can also go ahead and evaluate a similar type of information through the live data adapter once again. So if we go back to the live data adapter and launch the gap analysis, we can go ahead and take a look at the sensor data for all of the junctions and tank information. And we can go ahead and see what is the evaluation between the modeled and the measured data. And similar to ArcGIS dialog component, we can go ahead and tag, organize, or report so that we can create a sort of dashboard where we can view the information that we're plotting at the same time. So we can go ahead and evaluate this. Some other information that might be significant is maybe looking at the plump flow rate and the water treatment plant. You can kind of see how it behaves.
Yeah, so the some of the nice things about this dashboard is there's a number of statistics there, so you can kind of get a bird's eye view of all your different sensors and which ones are comparing well and which ones aren't. And that gap graph that Susanna clicked on in the lower right, you can put together multiple sensors and it will show all of them at once and just show the differences. So like if you do like all of your tank levels, you can see which tanks are deviating the farthest at different times of day. And then you can kind of toggle on the different comparison graphs, the lower left one, on demand to explore to explore into individual sensors if you wanted. So yeah, like at this point, kind of a question for the audience. What you know, this is kind of where it requires now the engineering judgment to kind of decide what do we need to then adjust next to fix in the model. And so you can actually see, yeah, Susanna, if you bring like the two tanks into the gap graph, I think that can tell us a bit. You see the two tanks. The
gap graph.
Yeah, sorry. Yeah, you can see the tanks are actually matching pretty well for the first several hours. And so part of that is because the SCADA run, so long as you just upload that CSV of all your sensors and you do that pattern like that Susanna did, it's going to pull in your initial conditions and it's going to pull in the demands that are calculated for each zone. So your model should actually then start off matching pretty well. And then now what's happening, you know, for the modelers looking at these tank graphs, and these aren't the actual tank time series. This is the difference in time series between tank model and measurements, but you can see they're starting to diverge as soon as the pumps kick in. And so it kind of indicates to us that there's something probably off with the pumps. And so yeah, as a modeler, you might start to ask, like, you know, where do I want to start, and which pump do I want to look at? Because, you know, a model, you know, this is a really small, simple model, but your model might have a dozen tanks that are all doing different things, and, you know, several different pressure zones. And so sometimes you can find like where one pressure zone is, you know, over, like the model is filling the tank too much, whereas the pressure zone where it's coming from, there's not enough volume in the tank. And so you can look at that pump where the exchange is happening, and sometimes fixing that one pump will solve both problems on both sides.
Yep. Yeah, and I think that's kind of something that the system schematic would help us, or the pressure zone schematic might help us identify.
Yeah, good idea. And
okay.
yeah, I think these windows, you can even have them open on your other monitor. So, and you can keep working. So yeah, let's take a look at the system schematic.
Yeah, so I went ahead and minimized it, and we can go ahead and bring about the system schematic. So yeah, I have it so that it automatically docks. But let me try to just have it floating at the moment. So right now we have just the breakdown of the different pressure zones. And I'm gonna go ahead and label the tanks and the pumps so we can go ahead and identify where these are located. And from here, we can go ahead and see that we have the two tanks, T5000, T5004, between these pressure zones, pressure zone 2, and we also have pump 140, which is feeding into T5000, or supplying to T5000, and also T5004. So since P140 feeds into tank T5000, we can go ahead and take a look at the controls of pump 140 and evaluate whether we can make some changes to that so that we can get a closer result to what is being measured by Info360. So I'll go ahead and bring up the control center overview feature, and this is also a floating dialog. So you can switch between dialogues, perform any operations that you need. If you have multiple monitors or a really large monitor, you can bring it to the other screen. So I just took it out of the screen and be able to evaluate what it looks like. Trying to not make it too cluttered. So if you could give me a moment to just kind of organize my dialogue so it doesn't look too busy. So right now we have,
Sorry. Oh, go ahead.
Oh, no, sorry. So anyway, so just to kind of emphasize, we were looking at pump 140 feeding into T5000 as we verified from the system schematic. And now between the control center overview, we can see what the controls are for individual pumps. So we can go ahead and see what is the control type, what are the commands. So in this case, pump 140 is turning on when the level is less than 78 feet, and it's turning off when the level at tank T5000 is greater than 97 feet. So if we wanted to go ahead and change this, modify this, we can actually go ahead and just double click on the cell for the specific pump under basic control, and it will launch the pump control editing dialog. And from here, we can proceed to make changes to this pump as we would if we were accessing it directly through the Model Explorer. So just to kind of show you the flexibility of the application, we can also go ahead and access the control editing dialog through the typical feature that has been in InfoWater Pro for a while now. Any comments on this up to this point, Nathan?
Nope. Yeah, there's many floating windows these days. So yeah, so hopefully you have lots of screen space and you can figure out the layout that you like to work in. But hopefully the different tools give you the ability to kind of navigate your model and understand what is affecting what, because that's often the challenge when you're diagnosing these big complicated models. So
yeah. Yeah, and from here, from this editing dialog, we can go ahead and make the edits that we want. So we're going to go ahead and raise the level at which point tank 5000 turns on to 80 feet. So we're just increasing it to up to 2 feet more. We're going to go ahead and update that and verify that and update. And then we can also verify that those changes have been made within the control center overview. So I need to refresh. And we have 80 feet listed in here. So we can go ahead and exit, or we can also set this aside if we want to keep playing with the controls. And we can bring up the control center, sorry, the live data adapter dialog back again.
Yeah, I think we need to rerun. Right?
And review the gap analysis. Oh, rerun the simulation. Okay.
Yeah, as she does that, if we did look at the, this is of course a little bit scripted, but if we would have looked at those graphs, you'll see that the tank is in the model, it's going down to 78, but in the measured data, it's only getting down to 80, and then the pump is kicking on earlier in real life than in the model. So so that's why that change from 78 to 80 was, could be a logical one.
A little look behind the screen.
Yep. And one of the questions as she's bringing this up is how does InfoWater Pro define that category on the right side? Wow, look at that beautiful calibration now. Just one setting you have to change, and things look good. So that category on the side, that good, fair, poor, green and red, that's a user-defined threshold based on I believe the average absolute difference. So it's not always the best. Actually, Susanna, can you click the color code options just to the right of the date? Yeah, there it is. So you can actually define it, the quality category. And so I think this is an absolute average difference measurement, which is not going to be, it's not going to be the best statistic for all sensors. So like our pump status sensors, I think those ones always are always going to get poor, unfortunately. But actually, if we close this, one of the statistics that we added that I think is pretty useful is the RSR, which is the second from the right column. So for those not familiar, this takes the root mean squared error divided by the standard deviation of the original signal. So it's going to be generally a somewhat robust statistic across varying sensor types. So you can pick and choose as the modeler which one you want to kind of go off and sort and use. But yeah, that was a good question that came up.
Okay. Yeah, so yes, we can see the results are much better aligned after making that change to the pump control. And this could be an iterative process. So essentially you could come here, play around with the controls, take a quick overview of what the individual controls are like for each one of these elements, and evaluate that. As of update 2, basic controls are accessible, but in future, we should be able to see other more complex controls as well and be able to access those editing dialogues as well. And I can show you because I have those that information at the moment, but that's essentially what it would look like, very similar functionality. Any other points that you want to make regarding various statistics, Nathan?
Nope. I think,
okay. All right. So at this point, we can, say that we're fairly content with the quality of our model. We can then proceed to use the upload to info360.com dialog to push or to upload our InfoWater Pro model to Info360 for collaborative modeling and just being able to evaluate our very well calibrated model. So I think this concludes the part of the InfoWater desktop demo.
Yep. Okay. Yeah, and I see we have 15 minutes, so I'm going to jump back to showing my screen to close out. And I see we do have a handful more questions. So I'm sharing my screen, right? You can see
Yep, the feature
mine?
demo.
Okay, great, thanks. Okay, so yeah, just summing up from there. So Info360 can bring your data. There's lots of visualization of the data that we didn't bother showing, but for modelers, you can bring over the initial hydraulic states. You can bring in control time series. Right now, that's in WS Pro, and we are working on that for InfoWater Pro, and you can also bring in the comparison graphs. In addition, so Susanna was showing how you can then upload the model. We have tools where you can then, within the web browser, do simulations using the model. So you can look at pipe breaks, for example, right now. So you can add a break on a certain pipe. You can simulate which customers are going to be impacted by that by just a basic inputs like we want to flag any customers that go below 30 psi for at least 30 minutes. And so then you can even see like a heat map over time of which customers become affected by that. And as well as you can see different valve operations. So these are little valves that pop up on the map because it will auto detect which valves are nearby in order that you could close to isolate. So you can do different scenarios of opening and closing valves at different times and so on. And there's much more coming in terms of web interfaces. Part of the theme that we want is now that we have the model data and the engine in the cloud and we have a web UI, we want to put modeling capability and model insight awareness in the hands of more people, even non-modelers, dare I say. And so, really the vision that we are that we're looking forward to is that Info360 can be a central hub where you can get your GIS, SCADA, IoT, CMMS, and InfoWater modelers, as well as our other desktop software, can exchange data with the cloud so we can have data collaboration. More is coming on that later, so stay tuned for InfoWater Pro users. And we can get on-demand computational power. Not available yet fully, but you can imagine if you want to run Fireflow for a large city, every hydrant within cloud, you could potentially just scale that out to limitless parallel compute engines on demand. And so you can do these large distributed things as well as valve criticality assessments. We can leverage cloud computing power in a fraction of the time and just pay for 100 parallel servers all at once for 15 minutes rather than investing in all that hardware locally, and then you have to maintain it long term. So on-demand computation is a no-brainer. We can get streamlined access for new users. So once we publish the model, we can do different things with it, as well as operational modeling, like what I said. And so there's going to be a growing suite of web applications where you can do model review, system planning, as well as operations. And I'm leaving this pretty vague because we can't speak too much in detail in the future, but I think at this point it kind of seems obvious what where we're headed, and so I think it's an exciting future. There was actually a couple questions that I saw in the chat around AMI sensor data. So that is certainly something we are working on as far as APIs to be able to directly connect to AMI sensor data. Certainly, we do actually have one project already where we are bringing in some AMI billing data, but we can't say that we guarantee an API connection to all the different companies out there. But we are working on that, and part of that problem is the scale of data. So certainly we can cloud is the way to handle big data, but all of that processing of input and storage, file read and write, and then the storage of that data, it can get costly if you don't do it right. So we are still working on some of the ways that we efficiently handle AMI data, but we have started on that process. So those are good questions. And actually, Let me see if I even have, oh no, I don't have my Info360 up and open, but within the mass balance that Hunter showed, there is an area for the billing data. So if you have a time series of billed like AMI data, we then calculate the total water usage, and you can subtract out what is billed to directly give you a time series of your non-revenue water. And that can then be used for alerts, dashboards, so like if you actually have hourly, full hourly AMI data, you could get an hourly time series of non-revenue water. And if that suddenly grows or jumps, that's a really strong indicator of a pipe burst or leakage getting worse in your system. So that's an exciting capability to be able to do a time series on that's then open for APIs and so on. Let's see, I also I just see lots of questions that I want to talk about, but one of the questions about I saw a former Innovise employee that had a bit of history with these SDA files. This is this whole user interface is actually something we are in the process right now of updating it to make it more intuitive. That was actually one of the features I was hoping to have ready by the time of this webinar, but you know how time schedules are when we're integrating with a much larger company. So priorities are always shift around, but we are in the process of making this much more intuitive. So at the moment, there's actually this file behind the scenes. It's a text file that pulls in all of those initial boundary conditions from Info360, and that gets fed into the engine. In the future, you're going to be able to select different events, and the SCADA file, it does get stored. So for those nerdy modelers that want to actually know where that file is and edit themselves if necessary, you can still do that, but it will automatically get associated by event. So in the future, you'll be able to pick your max day event, and so like maybe July 15th was your max day event. And you'll be able to calibrate your model to that date. But then you can also have a library of other events, like maybe if there was like a pipe break in April, you could actually map that event here. And then so from a SCADA run, you just change the event, all of the different files get coordinated with it. And so you can do your calibration. You can actually validate your calibration to other events. You could look at various operational change events that happen in your system, and it's all dynamic and at your fingertips as a modeler. And so I'm excited about that. So we weren't able to show that feature. It's actually being done in this current milestone. Within a few weeks should be out.
That just means
See.
next quarter when we have our what's new in Info360, we'll make sure we have you on so you can show that one off.
Yeah, Hunter, do you see any questions that we want to make sure we jump to in the last 5 minutes?
I know you mentioned, well, there is one that was asking about do we offer any training for entry/mid-level modelers could attend to understand the full differences between a traditional model and now this Info360 linked model. I wasn't sure if you wanted to kind of touch on the differences, kind of give a little bit more information on that.
Yeah, that is a great question. So this is actually not a real system. This is a model we call affectionately internally as Purple Town, which was actually created by one of the attendees of this webinar, who's been asking a lot of great questions. So thank you out there. So this is a fictional model, so we can actually use it for training purposes. So it is one of our objectives to actually create a training course within our Innovise Free Learning Center, so that InfoWater modelers that want to dip your toes into SCADA integrated modeling with using these SCADA runs, using that live data connection tool that Susanna showed, we'll actually have this model with a kind of like a sandbox site for testing available. So I don't think we can give access directly to the site, but at least we can walk through like with videos of a lot of the things that we showed and have that as an online training course. So yes, if you're wanting to learn more, we don't have that ready at the moment, but that is certainly a goal.
And then the only last one that I saw, and I think you mentioned you wanted to save it to the end, was the one about IW Live.
Yeah,
I wasn't sure if you
yeah.
wanted to comment on that.
Yeah, that is a great one. So IW Live is one of the tools that has a long history with it was one of the pioneers out in the market in terms of integrating hydraulic models with real-time data. And we have some mature utilities doing really cool things with IW Live, where IW Live will automate forecasts of your system. So like one utility, for example, they have varying energy charges, energy tariffs that can actually change day by day. And so based on forecasted energy changes, they use IW Live to forecast operations and predict what their operations are going to cost. And then they can actually tweak things within IW Live before they even implement. And there's other use cases that I think we have various case studies on our website. So IW Live has actually solved a lot of the technical engine integration kind of nuances for engineers in terms of bringing SCADA data into the model. Where it wasn't as strong, it was actually just democratizing that data with non-modelers. And so, so far, yeah, that is something we are definitely integrating with Info360. We're still working on the planning of it, but what I would expect is that we are going to leverage pretty much all. We're going to pretty much build upon the kind of the technical foundations of how IW Live integrates SCADA and models into the automated modeling within Info360, and then the dashboards and front end UI is going to get an overhaul. So if you own IW Live today, your investment is absolutely going to be leveraged into the future. You'll be able to take the projects and things that you've worked on into Info360, and it's I think it's safe to say there will be a compatible future for what you have done, and we're going to build upon that history that with that product. So yeah, we have 2 more minutes. Any other questions? Some good ones.
I think we got through all of them. I guess just touching on that is just some really exciting things, coming, and just keep your eyes on it. And I think our plan is to continue these what's new in Info360 on a quarterly basis, just so we can give people check-ins on what we've been working on. Nathan and the team over there have been working really hard. So just want to say thank you for everyone attending, and then Nathan and Susanna, thank you so much for hopping on and really helping run this.
Yeah, thanks everyone. Thanks, Hunter. Yep, and
Hey.
our recording should be up later. So thanks everyone. Have a good rest of the day.
And one last thing, if you do happen to want to send any more questions when you get the webinar, you will have my email address here. Feel free to reach out with any questions. I'll just keep rambling on to give you a second to screen capture this screen in case you want to have it on hand before then. Feel free to reach out with any questions, and we'd be happy to answer those or set up a call, whichever way is more efficient. So.
All right, thanks everyone. Bye.